CS8591 Computer Network, Unit 4, the first video, that is transport layer. We'll go to the problem. The first problem, assume that in a stop and wait system, the bandwidth of the line is 1 Mbps and 1 bit takes 20 milliseconds to make a round trip. What is the bandwidth delay product? If the system data packets are 1000 bits in length, what is the utilization percentage of the link? So they have given the bandwidth and the round trip time. So the solution is the bandwidth delay product is 1 into 10 power 6 1 Mbps into 20 milliseconds, 20 into 10 power minus 3, that is 20,000 bits. The system can send 20,000 bits during the time it takes for the data to go from the sender to the receiver, round trip, right, and the acknowledgement to come back. However, the system sends only 1000 bits, right? If the system's data packets are 1000 bits in length, right? So we can say that the link utilization is 1000 divided by 20,000. The link is capable of sending 20,000 bits, but it is sending only 1000 bits, or it is in terms of percentage, it is 5%. The utilization is only 5%. For this reason, in a link with a high bandwidth or long delay, we use stop and wait, wastes the capacity of the link. The second problem. Assume that in stop and wait system, the bandwidth is 1 Mbps and it takes 20 milliseconds to round trip time. And what is the bandwidth delay product? If the data packets are 1000 bits, what is the utilization percentage of link? If we have a protocol that can send up to 15 packets before stopping and worrying about the acknowledgement, the same thing, we have found out the bandwidth delay product, 1 millisecond into 1 megabits per second into 20 millisecond, 20,000 packet. So the system can send 20,000 bits during the time it takes data to go from the sender to the receiver. However, the system sends only 1000 bits. We can say that the link utilization is 5%, right? For this reason, in a link, we have this stop and wait system wastes the capacity of the link. So the bandwidth delay product is still 20,000 bits. The system can send up to 15 packets or 15,000 bits during the round trip. This means that the utilization is now 15,000 divided by 20,000, that is 75%. So if a protocol that can send up to 15 packets, the link utilization is 75%. So if there are damaged packets, the utilization percentage is much less because packet has to be resent. The next problem is, the following is the content of UDP header in the hexadecimal format. So CB84000D001C001C. This is the UDC header format. What is the source port number? What is the destination port number? What is the total length of the user datagram? So the first source port number is first 4 hexadecimal digits. So CB84 is the source port number, which means that the source port number is 52,100. Then the destination port number is second 4 hexadecimal digits. So 000D is the second 4 hexadecimal digits, which means that the destination port number is 13. The third one, the length of the user, the third 4 hexadecimal 001C, which defines the length of the whole UDP packet as 28 bits, right? This is CB84 is the source port number, 000D is the destination port number, 001C is the length of the packet. We will see what is the remaining thing. What is the length of the data? So the length of the whole data packet minus the length of the header. So 28 is the length of the whole packet minus 8 is the 20 bytes, right? 20 bytes is the length of the data. Since the port number is 13, that is a well-known port number, the packet is from the client to server, right? So the last question is, what is the client process? The client process is the datetime, right? So these are all the details about the UDP header, right? We'll go to the